Hello, today's topic is the grand solar minimum. The reason I put this topic together is because this is something that I have researched and become interested in, and I have not found a good, concise resource that explains this in a simplified manner on the internet that I can refer people to. So I put one together myself using resources that I pieced together from various sources. What I'll be talking about is I'll try to explain what is a grand solar minimum. This is a topic I've tried to explain to friends and family, and nobody knows what it is, and it's hard to just verbally describe it. So it's very important to have the images. It really helps to explain it. I'll be talking about what effects we see with a grand solar minimum on Earth, what evidence is there that a grand solar minimum is imminent, and if it is, what can we do about it? In order to understand grand solar minimum, you have to understand the sunspot cycle. What are sunspots? Sunspots are dark spots seen on the sun, and when they're present, they indicate that the sun is more active than when the sunspots are absent. These sunspots can be observed with telescopes, and they wax and wane in 11-year cycles. And these sunspots are a proxy for total solar activity. This chart shows a 400-year sunspot observation. You can see the sunspots wax and wane in these 11-year cycles. They peak up, and you get to 200, 250 sunspots when these cycles are very robust, and then it drops down, and typically an 11-year cycle. But you also notice that longer term, there are some cycles have higher sunspot numbers, and when you have several cycles in a row where the sunspot number does not peak as much as normal, that's called a grand solar minimum. When the sunspots peak very highly, like they have for the last 100 years, that's called a grand solar maximum. The last major grand solar minimum we had was during the Maunder Minimum of 1650 to 1720. Lasted about 6 sunspot cycles, 6 11-year cycles, so about 70 years. We also had a shorter sunspot grand solar minimum during the Dalton Minimum of the early 1800s. The Maunder Minimum of 1650 to 1720 manifested as profound changes in the climate. There was some small degree there was some cooling that was seen, but primarily there was shortening of the grow seasons, some periods of excessive rain, but also droughts were seen. And these climate changes resulted in crop losses, with some years having food price spikes of 2, 3, 7 times normal food prices, which resulted in regional famines and incidents of pandemics. So the year 1816 was known as the year without a summer. This occurred during the Dalton Minimum, and during this time there were hard frost in every month of the year throughout New England, so the corn crop was a total failure. This was precipitated by the eruption of Mount Tambora in 1815. So artists during this time painted what they saw, and what they saw was a sky full of clouds and lots of rain. This occurred during the Dalton Minimum and resulted in some hardships regionally, particularly through New England. This map shows temperature changes seen during the Maunder Minimum. So during the Maunder Minimum, temperature on average dropped, particularly in the northern hemisphere, but it didn't drop everywhere. There were some areas that were actually warmer. The Alaska and southern tip of Greenland saw a little bit of warming, but there was a measurable drop in temperature throughout Canada and northern United States, northern Europe, and across Russia, and some in northern Africa. The amount of temperature change that was seen was only about 1.3 degrees Celsius. So this was significant, but it's not a huge drop in temperature. So the changes that were seen from a climatological standpoint, resulting in the crop losses, certainly the temperature affected, but also it was through a complex change in weather patterns. And we'll explain later more about that. This is a busy little chart talking about the temperatures, reconstruction based on Greenland ice cores. And this goes back a long time to about 3,500 to 4,000 years ago. And the blue line is temperature reconstruction from the Greenland ice core, which the data only goes to about 1855, and then since that, the red line is a actual temperature based on the records that we have. And you can see there have been times where, based on this data, we've had warmer temperatures, and each time we have warm temperatures during grand solar maximum, civilization flourishes. When the temperature drops, there is collapse of certain civilizations. So we had the Minoan warm period about 3,500 years ago, when temperature began to decline. The Mycenaean civilization collapsed. The Hittite Empire fell. The Shang dynasty collapsed in China. When temperatures began to warm again, we had a Roman warm period. The Roman civilization flourished about 2,000 years ago. When it cooled again, there was a splintering of the Roman Empire into numerous parts. We had a little bit of warming, and then we went down into the European Dark Age. Around 784, there was starvation, extreme cold. A third of the European population died during that time frame. Then we went into a period of warming, the medieval warm period. Vikings settled in Greenland and Newfoundland. Then we had some cooling again. And we descend into a 500-year period called the Little Ice Age. We had the Great Famine, the Black Death. Glaciers grew and destroyed villages. We had the Maunder Minimum during this time. And then we've come out of that with the grand solar maximum that we're in now, the modern maximum. And we're in a period of significant warming with the modern warm period. In order to understand how the grand solar minimum affects the Earth, we have to understand how can the sun affect the Earth's climate. One way specifically it affects the Earth's climate is through total solar irradiance. So when the sun is less active, we receive less irradiance from the sun. But the amount of drop in irradiance is pretty small and does not fully explain the effects that we see during these grand solar minimums. So there must be other mechanisms in play. One other mechanism is cosmic rays and the effect on cloud nucleation and volcanism or volcanoes. Another mechanism is the UV effects on ozone, and it's particularly ozone at the poles, and the effects on the jet stream. So this is a chart where the top chart shows total solar irradiance. And you can see that it drops during the Maunder minimum, comes back up, and drops again during the Dalton minimum, comes up. We had a little drop in what's called the Gleisberg minimum. It's not labeled there. And then it comes up. We have had an increase in total solar irradiance during the modern maximum. And this total solar irradiance certainly correlates with these minimum maxima sunspot observations. But if you look at the left side of the chart, the amount of change here, this chart doesn't go down to zero. So you're talking about a change of really 3 to 4 watts per square meter out of a total of 1,366 watts per square meter. So it's a minimal change in total solar radiance. Really would only account for about 1/3 of a degree Fahrenheit or so in temperature change. So there must be other factors at play to account for some of the changes that we've seen during grand solar minima. One other factor that is in play is our cosmic rays. So cosmic rays actually aren't rays; they are high energy particles that move nearly at the speed of light, very, very, very high energy, and they originate mostly from distant galaxies. Some come from our galaxies, but they are the result of supernova, collapsing stars, black holes. These are incredibly energetic particles. When they hit our atmosphere, they produce showers of secondary particles as they cascade through the atmosphere that results in ionization of the atmosphere. This chart shows on the blue line on the top the cosmic rays. and an increase in cosmic rays during each of the grand solar minimum. This bottom line are the sunspot numbers. Each time the sunspot numbers decrease, there's an increase in cosmic rays. And the cosmic rays have been decreasing during our grand solar maximum until recently, when they begin to increase again. This chart is a more recent chart from 1964 to 2019. And you can see on the top the sunspot numbers. So this is the 11-year sunspot cycle. Each time we go into an 11-year solar minimum, you can see the cosmic rays increase. But as these sunspot cycles decrease in in power, the cosmic rays have been increasing, and we are now at close to a space age maximum on the cosmic ray. Cosmic rays that have been coming into the Earth. This is important because the Sunspot hypothesis states that these cosmic rays have an ability to create seeds to form low-lying clouds, and these clouds increase the albedo effect, the reflectivity. They reflect a lot of sunlight. So you recall that our decrease in total solar radiance was about 3 watts per square meter. A cloud can reflect about 33 watts per square meter, so it can have a big effect on climate. This is a study from Peru showing a very good link between low cloud cover in blue and cosmic rays. This is not without controversy, and there are other studies where the correlation was less robust, and there have been other studies that did not show a good correlation. This is not settled science, but there are studies showing a correlation between low cloud cover and galactic cosmic rays. This, again, is a more detailed explanation of the Sunspot hypothesis that states that when these cosmic rays enter our atmosphere producing these secondary ionized particles, they interact in complex ways with certain trace gases in the atmosphere, water vapors, sulfuric acid, to produce very small ion nucleation that can grow by condensation and result in cloud nucleation and formation of clouds that can reflect sunlight and drop rain. So an overview: during a grand solar minimum, the sun's magnetic field, the solar magnetic field, is weak. More cosmic rays can penetrate the Earth, seeding clouds and result in a cloudy, cool Earth, reflecting that sunlight back out to space. During a grand solar maximum, the solar magnetic field is strong, blocking the entrance of cosmic rays, resulting in clear skies and a warmer Earth. We talked about how during a grand solar minimum there can be an effect on volcanism. This was a study showing that during solar minima, there is a statistically significant increase in explosive volcanic events. So these cosmic rays are extremely powerful and certainly can cascade through our atmosphere, but they also deeply penetrate into the Earth and interact in complex ways with silica-rich magma. In a way, if you remember from high school chemistry, when you would boil something, you always had to use a boiling rod. If you didn't, you would overheat your solution, and then it could explode. So the silica-rich magma under pressure is kind of like a supersaturated solution, and then when these cosmic rays interact with the silica-rich magma, it can precipitate boiling and explosive events, and this is borne out in some scientific studies. So there is an increase in volcanism during grand solar minimums, and this can have a tremendous effect on atmosphere. These very large volcanic eruptions can release millions of tons of aerosols and ash into the atmosphere, and if the volcanic eruption is strong enough, it goes into the stratosphere. The aerosols remain there for a very long time. And we saw this, in the year without a summer in 1816. The volcanic particulates then can interact with the cosmic rays to result in very rapid cloud formation and cloud nucleation. We talked about another mechanism by which the grand solar minimum can affect the weather patterns, and this is a big one here. When the sun is very active, these UV rays come in and interact in complex ways with the atmosphere, and it can destroy ozone. And when you have less, particularly at the poles, so when you have less ozone in the mesosphere at the poles, the jet stream stays very strong and comes across in a west to east pattern with very little meandering, and it results in very stable weather patterns. When the sun is less active, you have less UV destruction of ozone, and you get more ozone accumulation in the mesosphere, particularly over the poles, and you can get a breakdown in the jet stream. So the jet stream, instead of coming straight across, takes a more meandering north-south pattern as it comes across, resulting in very severe weather patterns, severe, prolific rains, but also droughts, depending on where you're at, if you're getting that cool, dry air or if you're getting that warm, moist air. This is known as the Arctic Oscillation. When you're in a positive phase, you've got nice stable weather. When you're in a negative phase, you get these big meandering jet streams that are more north-south, and it drastically affects weather patterns. We saw this in early 2019. There was a polar vortex where the cool, dry air dropped down for 2 or 3, 4 days over parts of Canada and the upper Midwest. And it was extremely cold at that time. So, this is a complex topic. It's a complex process. When the sun loses power, you get an increase in volcanism. More clouds to block the sun. When the sun loses power, you get more cosmic rays, more cloud nucleation, more reflection of sunlight back to space, and you can get crop failures. When the sun loses power, the grow seasons can shrink, and you can get food price increases, food shortage, and civil unrest. Bad things can happen. So signs and symptoms of grand solar minimum. These are what we've seen throughout history during the grand solar minimum of the Maunder Minimum, during the Dalton Minimum, and this is what we would expect if we see a grand solar minimum. Periods of extreme weather in all categories, record cold and hot temperatures, but also record droughts. Record rain, where you have these atmospheric compression events where you get a year's worth of rain in 24 hours, massive floods, record hail in size and severity, extremely cold winters, particularly in the northern latitudes, grow seasons becoming shorter, particularly in the northern latitudes, grow zones shifting further south, greening of the deserts can be seen, massive electrical storms, very wild weather, and early frost in the fall and late frost in the spring. Interestingly, I put this presentation together before the coronavirus pandemic, but during the grand solar minimum, every grand solar minimum on record, the Sporer minimum 1450 to 1550, the Maunder minimum 1650 to 1720, the Dalton minimum during the early 1800s have all been marked by a preponderance of pandemics, smallpox, English sweats, the plague, cholera. During 2009, we had a swine flu pandemic. That was not during a grand solar minimum, but it was during an 11-year solar minimum. Recently, we've had African swine fever that resulted in China having to cull most of the pig herd. We've had, and of course, this coronavirus. I plan to do a separate videos on the coronavirus. This coronavirus is it's a serious thing, and we'll be talking more about it later in other videos. So we got an understanding of what a grand solar minimum is and what effects we might see. It is one imminent. Okay, what evidence is there that one is imminent? Well, we have Dr. Valentina Zharkova's study. We have NASA's own predictions. We have a study on planetary alignments, and we also have current climate changes that we're seeing. So let's go through these. Dr. Valentina Zharkova, smart lady, mathematician, astrophysicist. She, you can find her presentation on the internet, on YouTube. I listened to it, so you don't have to. But she's, I think she's right. She's onto something. She's predicting. She modeled the sun mathematically. She's predicting that the next 3 solar cycles will be a grand solar minimum, 2020 to 2053, and we'll see the most changes probably around 2030, 2040. So, like I said, she modeled the sun's magnetic field, and she found there's magnetic waves. The sun's kind of a dynamo effect. And this is a complex thing that I don't have time to go into. You're welcome to listen to her presentation. But she's saying that the sun is going to go out, these magnetic fields are going to go out of phase, and we're going to go into a period of grand solar minimum. This is a representation of her dynamo model, and essentially, in a simplified form, the wave amplitude is essentially the amplitude of the sun's magnetic field, and every 350 to 400 years, we get a grand solar minimum. There are smaller minimums in between, but this last one, 1650 to 1720, was the Maunder Minimum. That was a longer grand solar minimum. Her predictions say that we are heading into a grand solar minimum that's going to be shorter than the Maunder Minimum, but still fairly severe, 2020 to 2053. That's where we are right now. NASA's own scientist, Irina Kirishvili, I don't think I pronounced that right, but has been studying solar cycles. And, solar cycle prediction is not a settled science by any means, but Irina Kirishvili has been modeling the sunspot cycles and put together a prediction for solar cycle 24 that was spot on. Now, NASA's other scientists predicted that solar cycle 24 was going to be much stronger than solar cycle 23, about twice as strong, and it wasn't. They were all wrong, except that this scientist was right. So what does Irina Kirishvili's prediction say about the next solar cycle? Well, the prediction is that the next solar cycle will start in 2020, and is expected to be 40%, 50% weaker than solar cycle 24, which is weaker than the one before, which is weaker than the one before. So we're in a declining trend of solar cycles. This is a 200-year representation. Here you can see the Dalton minimum sunspot numbers. According to this NASA's prediction, this next solar cycle will be the weakest in 200 years, weaker than the Dalton minimum. They didn't make a prediction about the 2 cycles after that, but nonetheless, this is something that should be listened to. Another piece of evidence that we have that we're heading into a grand solar minimum is the planetary alignment. So what causes the sun to go out of phase? What causes this this cancellation of the magnetic fields? Well, the answer is it's probably the planets. So the planets, as they orbit the sun, particularly the larger planets and the ones that are closer in, Jupiter, Venus, Saturn, and Earth, have a very small but significant tidal pull on the sun. And when the planets align in certain ways, that tidal pull can be slightly increased enough to flip the sun out of its magnetic phase and throw it out of phase. It's called a phase catastrophe. So certain studies have looked at this, and they said, and looked at the planetary alignments and the tidal pull in the prior grand solar minimum. And in each case, there's certain planetary alignments that occur that result in an increased tidal pull that flips the sun out of phase. These studies suggest that we are heading into a phase catastrophe now. And this will result in the onset of a grand solar minimum that will cause a disruption for 3 solar cycles. So some of these studies are lining up, and again, this is not settled science. There are other the scientists do not all agree on solar cycle prediction. Nonetheless, I think we should listen to this and listen to some of these scientists and see and think about it and see if that makes sense to us. So we've seen certain weather changes that would suggest that we are already proceeding into a grand solar minimum, especially in the areas where we saw the weather changes during the Maunder Minimum. So if you know where to look and what to look for, you can already start to see some changes that make sense. This is especially evident in the northern latitudes throughout Canada, North Dakota, South Dakota, Nebraska, Minnesota, Wisconsin, Northern Europe, Russia. During the winters of 2018, 2019, and 2019, 2020, we saw record snowfall events, particularly across Colorado, Canada, California. We had the wettest 12 months on record throughout the United States. And our records go back 125 years. And the amount of rain that we received in the United States was unprecedented. This is what we saw. So this was not just one or two states. This was the entire upper Midwest, South Dakota, North Dakota, Nebraska, Kansas, Minnesota, Iowa, Missouri, Wisconsin, Illinois, and also some throughout Indiana, and to a lesser degree in Ohio. This was biblical flooding. And unfortunately, the farmers had been storing up a lot of grain because of the trade war. It's estimated, 30 to 38% of all U.S. supplies were destroyed at that time. So it was a disaster. Farmers couldn't get in the field to plant, it was not a good year for the farmers. I know farmers who had 1,000 acres, half of which they couldn't plant. And the half they did plant had decreased yields of about 10%. This was not a good year for farmers. In addition, we had a few areas that had a little bit of drought this year, not every place, but certainly throughout the upper Midwest, Canada, North Dakota, South Dakota, there were early blizzards came in September, November, that resulted in difficulty getting the crops out of the fields, and a decline in the quality of the grains. So many of these grains were wet and are no longer graded or suitable for human consumption. Instead, they were downgraded to animal feed or just lost altogether. So we talked about what is a grand solar minimum, what kind of things, how has it manifested in the past, what evidence there is that we're heading into a grand solar minimum, but now what can we do about it? I invite everybody to think about this. Do your own research. Don't listen just to me. Some good resources out there. There's some YouTube channels, Adapt 2030 and Ice Age Farmer, that go into things more detail. I don't always agree with everything they say, but it's certainly a good resource for very detailed news relating to these topics. There's other resources. Nextgrandminimum.com has been a good resource. And look at Dr. Valentina Zharkova's study. That's really what got me interested in this. Is I saw her study, I read it, and I watched her presentation, and I hear the truth in her words. I mean, she believes what she says, and she believes that we could potentially see food shortages around 2030. Now, those things are hard to predict. She's not a climatologist; she's an astrophysicist. But I think her work is fairly sound. But what can we do? So number one, you want to take responsibility for your food security for you and your family. And number one is grow your own food if you can. If you live in the city, you may want to stock up on some long-term, long shelf life foods, but also look in the community gardens and other options. But if you have a little bit of land, it doesn't take a whole lot of land. If you can start growing, 30-40% of your own food, that's a good step. You want to consider an alternative energy source, particularly if you're in an area where you get ice storms and electricity could go out. You want to think about a wood stove or a backup generator. If you think about our traditional methods of agriculture really failed this year in some ways. Concepts like permaculture, where you're doing more perennials and you are able to have crops that actually produce rather than having to get in and work the field. If you can find ways, very, very high intensity agriculture that is less disruptive to the soil, particularly when the soil is wet. What grows well in cool, wet weather? Well, not a whole lot of things, but there are some crops that do better in cool, wet weather, and we'll go through some of those. And there are certain crops that are more for warm weather. You think about tomatoes and watermelons, corn and beans, but there are certain cultivars of those warm weather crops that are better able to tolerate shorter growing seasons and cooler, wetter weather. And you can consider greenhouses to augment your food growing, particularly to extend your growing season. But most importantly, if you're going to grow your own food, you want to get some heirloom seeds. You don't want to rely on the GMO or hybrid things. You want to get some heirloom seeds. You want to start doing this now. I think we may have time if this manifests. We may have time before 2030. But you want to get the seeds in the ground and let them start adapting to your local areas, and try to think and find what works for you. And gardening, as I've found, has a steep learning curve, and you want to start making your mistakes now and get better at it. And it's a fun hobby. So if none of this manifests, it's a good excuse to go out and garden and get outdoors and get healthy and eat better. There's no downside to this. Long shelf life foods, dried beans and rice are not very expensive right now. We have seen an increase in food prices about 10% over the last year. So not a huge spike, but don't be caught off guard. That's why I'm doing this, so that you can think upon it and think what makes sense. Foraging skills can be beneficial. There's a lot of things you can eat at the edge of the woods or in your own yard, and that's beyond the scope of this little broadcast. But some good resources there. There's an excellent YouTube channel that's called Learn Your Land with Adam Harrington, where he goes through edible and medicinal plants. Highly recommend that. Learn Your Land is the name of that. But I also encourage you, if you think this might be a real thing, to develop, spread the word. Share this video. Develop some community awareness, because you don't want to be the only one around that has a garden. You want your community to thrive. And we can thrive. We've been through grand solar minimums before, and we've always survived. These happen every 350 to 400 years. This is a natural cycle. But you can thrive better if you can anticipate that this is a possibility. We talked about energy considerations. Generator and wood stove might be good options if you live in a cooler climate. We talked about cool weather crops. There's the root vegetables can tend to do better during cooler, wetter weather. Things like beets, carrots, turnips. Sunchokes, I think, are potentially a good choice, particularly the ones that are adapted to a northern climate and are adapted to a shorter growing season. I think those might be good for people who aren't very good at farming, because it's hard to kill them. So you got to be careful where you plant them. They will kind of take over. Parsnips, potatoes, onions, garlic, kohlrabi, radishes. The root vegetables can tend to do okay. And the other things, the greens, arugula, spinach, broccoli, cabbage, cauliflower, collards, mache and claytonia are a type of like a lettuce subtype that do very well, very tolerant to cooler weather. Brussels sprouts, kale, and of course mushrooms. So these are options, and we'd also talked about the typical vegetables you think of for a garden, the tomatoes and beans and corn. But if you can find the cultivars that can be somewhat tolerant, like I was looking at melons the other day. There's a cultivar. Melons are a hot weather crop, but there's a cultivar called the Minnesota midget, which it's been grown in Minnesota for several generations and is tolerant of the shorter growing season. So it's a smaller melon. If you like melons, you don't want to give up your melons. That's a good option. But I invite everybody to think about this, and we read in our family, we read a book, Little House on the Prairie, and it's a good book series. I highly recommend it. But there was a story there when Paul went to work on the railroad, and they moved the family to South Dakota, and Paul was up there, and they had their claim out in the woods, and then they had a little house in town. Paul's out cutting hay and noticed that the muskrat houses that fall had walls twice as thick as normal. And Paul kind of scratched his head, and he was talking with Laura, and she said, well, how do the muskrats know? And Paul said, well, God just tells them that the winter's coming and it's going to be colder than normal. I said, well, how do we know this? And he said, well, God, God gave us a brain. We got to figure things out for ourselves. And then he kind of scratched his head a little bit and thought on things. And then that next day he went into the general store, and the Indian came in, a Native American came in and talked to all the white men there, and said, you white men don't know what's coming. This winter is going to be a bad winter. And the Native American knew. And so Paul, at the dinner that night, he said, I've been thinking, I think we'll move our family into town for the winter. They didn't really have any worries because the train was coming through, and every week the train would bring supplies with coal and wheat and whatever they wanted. So they didn't have any worries. Well, lo and behold, that winter was a bad winter, and then a blizzard swept in October. Lasted 3 days, and then they had blizzards every 3 days. It lasted 2 or 3 days, and the trains quit running. And these were hardy pioneer folks. I mean, these were, and this whole town almost starved to death. And Paul had remarked before all this started. He said, this kerosene and the train, everything. These things are real nice, but the trouble is, people get used to them, and they get dependent on them. And think about that. Think about our just-in-time inventory. Think about how dependent we are on things from China, and your food security, and start taking responsibility for that, and do what you can to mold us over. I mean, we've had a time of plenty, and it's hard to predict the future, so it doesn't hurt to be prepared. So thank you for listening. Please share this, and I appreciate everybody listening. Thank you.